Recording in progress.
Hey there, everybody. Welcome back. We are going to start chapter 3 today. Chapter 3 is on polynomials. And our first section is on exponents. So 3.1 is on exponents. I'm going to do a couple of videos, break it up into 2 videos. The first video will be the rules of exponents and where they come from. And the second video will be just an example video. All right, so what are exponents and how do they work and stuff? We've talked about them for order of operations. If we have like x to the 5th, this is the x is called the base. 5 is called the exponent. We also call it a power. And it represents how many times x is multiplied by itself. So the rules or properties that go with exponents, I'll give the property and an example. So properties. First property, if I have a to the m power and I multiply by a to the n power, I get a to the m plus n power. An example would be, well, let's use x squared times x cubed. This is x times x for the x squared. And then we have times x times x times x for the x cubed. We can see that ends up being x to the 5th power, which is 2 plus 3. Hi, honey. Second property. If we have a to the m power and we raise that to the n power, we get a to the m times n. This is like x squared cubed. The cube says multiply this together 3 times. And this is 2 times 2 times 2, or 2 plus 2 plus 2. Another way of writing that is 2 times 3. Repeated addition is multiplication. So we end up with x to the 6th power there. Next rule, where we have division. A to the m over a to the n. Is a to the m minus n. If I have x to the 5th power over x squared, this is what I really have. These can get canceled out. And I'm left with x cubed, which is x to the 5 minus 2. All right. Now we'll do some more. We'll have a to the m power and b to the n power. And we'll raise all of that to the p power. This is a to the m times p, b to the n times p. So an example, x squared y cubed squared is x squared y cubed times x squared y cubed. And we rearrange it to put the x's together. And this is following property 1. So x to the 2 plus 2, y to the 2 plus 3 plus 3. That is repeated addition. Repeated addition is multiplication. Okay. So 2 times 2 and 3 times 2. Number 5's just the same thing, but doing division. And it follows the same reasoning as number 4. Now we'll look at negative exponents. This is the same thing as 1 over a to the n. And we'll do 1 over a to the negative n is the same thing as a to the n. Where does this come from? Let's look at how x squared to the 5th power, not to the 5th power, x squared over x to the 5th, how we can tinker with this. By property 3, I can say this is x to the 2 minus 5, which is x to the negative 3. That's from property 3. Or I could rewrite it as x times x over x times x times x times x and cancel them out in pairs. And I'm left with 1 over x cubed. And that has to equal x to the negative 3. Okay. And the final rule you can see kind of derived if I do x to the 5th power over x to the 5th power. They all cancel, right? All of them on top and bottom cancel each other. I'm just left with 1. But if I do the subtraction rule, this is x, which is 5 minus 5. So rule number 7 is anything to the 0 power is 1. Not anything. A can't approach infinity. Oh, look at. Is that Epic Games or Steam? I think it's Epic Games popping up. All right, those are the properties. There's 7 of them. Next video, we will use them. Peace.